This video is about slopes and rates of change. Slope is going to be new to us, and rates of change we have already seen before. So rates of change are basically when we have a table and we're figuring out that we're subtracting 2 here and adding 2 on the x-axis. And if we remember, we did the change in y, so the change in y here over the change in x. So what we would have is negative 2 over 2, which actually reduces to negative 1 over 1, which is negative 1. Okay? And remember that all 4 terms mean the same thing. So we have change in y over change in x is the same thing as rise over run. And that's what we're about to learn about. And that's the same thing as rate of change. And rate of change is the same thing as slope. So really all 4 of those terms mean the same thing. Okay, a zero slope and undefined slope. We've seen both types of these graphs. But when we figure them out, okay, I'm going to pick 2 points here. So one here and one here. And if we were to put that on a table, the first x value is 1, y value of 4. The second one, x value is 2, y value of 4. When we're figuring out rates of change, 4 to 4, I'm going up 0. And from 1 to 2, I'm going up 1. So when we do the y over x, I have 0 over 1. 0 over any number is going to be 0. So it has a 0 slope. So if we have a horizontal line like this, the slope we're going to say is 0. So this has a 0 slope. Undefined. Let's pick 2 points here. So I'll pick this one and this one. So when we make our table, I have negative 2, 1, and negative 2, 2. So now here, I'm going up 1, and over here, I'm going up 0. So now I have 1 over 0. You cannot have a number over 0. So this is going to be considered undefined. This is an undefined number giving us an undefined slope. Now if we remember, okay, a vertical line is not a function, so this is not a function. And if it's not a function, it does not have a y value. So if we remember from in class, if both x values are negative 2 or all values are negative 2, this equation actually looks like x equals negative 2. Because on this line, each point, no matter how far we go up or down, so if I was going to be down here, my x value is negative 2. If we're looking over here at this one, my y values were the same. Okay, this one was a function. It did pass the vertical line test, but all my y's are going to be 4. So this equation is going to be y equals 4. And it's 0 because it's not going up. It's staying the same. We don't have an x value. So anytime you have a y but not an x, you're going to have a 0 slope. Okay, the greatest rate of change. This is the greatest absolute value of the slopes. So what we're going to start by doing first is plotting points. So I have a beginning point here and an end point here. This is also the beginning point and end point here, a point here, here, and here. So when I plot these points, I'm going to start by going left to right. I have 115. This is 325, 425, 545, 950, and 1040. So the slope of the line, that's how much it's rising okay, rise over run, or the rate of change, how fast the rate is changing. Now the way that we could figure it out on a graph. Okay, on a graph, we're figuring out our change in y. So my change in y here is 15 to 25, so I'm actually rising 10. And that's where this rise over runs comes into play. And I'm running, I always run forward, so I always go left to right. I'm running from 1 to 3, so I'm actually going 2 spaces. So my change in y or change in x is 10 over 2, rise over run. So 10 over 2, which is actually going to reduce to 5. Okay, or 5 over 1. Now to show you how it works over here, from 1 to 3, I'm going up 2. From 15 to 25, I'm going up 10. So my y over x will be 10 over 2, which reduces to 5. Okay, the next one, I'm going from this point to this point. I'm not rising any, so my rise is 0. Okay, and my run, I'm moving 1. So over here, my x, I'm going plus 1, plus 0. This is 0 over 1, which gives me 0. So this is a 0 slope. The third one, I'm rising from 25 to 45, that's 20. I'm running, and we're always going to go left to right like we're reading a book. So I'm running 1, because from 4 to 5, that's 1. So my rise is 20, my run is 1. So that's 20 over 1, which is 20. So here, I'm going up 1, over here, 10. Sorry, 20. 25 to 45 is 20. So that's going to give me 20 over 1, which is 20. The fourth, I'm rising 5, but I'm running, let's see, these are going by 1, so 1, 2, 3, 4. So run 4. So it should be rise 5, run 4. So let's see over here, 5 to 9, that's positive 4. 45 to 50 is positive 5. So y over x is 5 over 4. And then the last type we have is actually decreasing. So we're still going to go left to right, but I'm always going to run forwards. Okay, so I'm always going this way. So I'm moving 1, but now I'm falling. Okay, I'm going down. So instead of rise, I'm falling. So I'm going down 10. So I'm going to go negative 10 here. So my rise is negative 10 over my run of 1, which is going to give me a negative 10. So here, 9 to 10, positive 1, 50 to 40 is negative 10. So I have negative 10 over 1 to give me negative 10. So now I found the rates of change. So to find the greatest rate of change, I'm seeing basically which number is the highest number, but I'm not giving any value to the negative. So here I have 5, here is 0. So 5 is the greatest rate of change. But between 5 and 20, 20 is the greatest number. 20 and 5 over 4, 5 over 4 is 1.25, so 20 is going to be the biggest number. And 20 and negative 10, I disregard the negative right now because I don't really care if I'm going up or down. I'm just worried about the slope, which one has the greatest rate of change, no matter if it's going positive or negative. So it's basically a 10. So I have 20 and 10. So my greatest rate of change right now is 20. And it's this area right here, this line that's going up. That's my greatest rate of change. Okay, I'm identifying the rates of change on this graph. The easiest thing for you to do is pick points that run through corners. So if I look here, these are all running through these points. So you can do one of two things. We can either create a table. I'm going to pick this point 1, 1, and this point 2, 2. And since it's linear, we know it's going to continue on the same track. So I'm going up 1, and this one's going up 1. So I have 1 over 1, which is 1. Or what we can do is do rise over run. So from this point to this point, I'm going up 1, run 1. So 1 over 1. So my rise is 1, my run is 1. Now, let's say you skipped 1, and we went from this point to this point. My rise would be a positive 2, my run would be a positive 2. Now, rise is 2, run is 2. That number still reduces to a positive 1. So even if you miss a point, it's still going to reduce to the same number. And we can go rise 1, run 1, and there will be your point right there. Okay, here we go again. I have a point here. I've got a point here. And it's supposed to be going through that point there. So what we're going to do now, my rise goes down, so negative 1. My run is 1, 2, 3, 4. So it's 4. Your run's always going to be positive because you're always running forwards like you read a book. So rise is negative 1 over my run, which is 4. So the slope of my line is going to be negative 1/4. What that means is, if my slope is negative 1/4 here and it's linear, I can keep going. So I can go down and over 4. There's a point. I can assume I could keep going down 1 over 4, and there would be a point that I could continue this line. Also, you can follow this pattern backwards. So once you go forwards, you run forwards, then I can say, okay, I went back 4, up 1, back 4, up 1, back 4, up 1, and you can continue to go back 4, up 1, and have a point that way. The next one, I have a y-intercept of 2 here, and I'm going through a point here. So this rate of change, let's see, I'm going down 1, 2, 3, so negative 3, and running 2. So my rise is negative 3 over my run of 2. Now if you'll notice, this number is negative. Negative 3 over 2. Anytime your line, as your x increases, if your y is decreasing, okay, so basically your rise is negative, we're also going to say that this graph has a negative slope. Okay, so just a little hint for you. I have the little face in my room. You can look around. It looks like this. This is one eye, positive. So if the line's going up, it's a positive slope. Line's going down, it's a negative slope. The line is vertical, undefined slope. And if the line is horizontal, 0 slope. So it actually makes a little face. That's what all of those mean. So if the line goes up, positive. Line goes down, negative. Vertical, it's undefined. And horizontal, it's 0.